See, the problem is, the numerical is a bullet of mass 0.04 kg. This is example question number 5.4. Now, mass is how much? The mass is 0.04 kg. The way to solve the problem is also important. First, write the given details. In moving with a speed of u equal to how much? 90 meter per second, enters a heavy wooden block and is stopped after a distance of 60 centimeter. So suppose there is a bullet. So this is the bullet, and this is the block. Now this is the initial state. So u is given to you, and this is the mass of the, and small m is the mass, and capital M is the mass of the block. So this bullet will go in the block and gets embedded into it. Stopped after a distance of 60 centimeter. 60 centimeter. So now, what is the average resistance force exerted by the block on the bullet? So distance is equal to how much? 60 centimeter. Convert into meters, 0.6 meters. He is asking what is the resistive force. Okay. So first calculate the acceleration. So how do we calculate? First calculate acceleration. So v square minus u square equal to 2as, and final velocity is 0. 0 minus 90 square equal to how much? 2as. 2 into a into s. S is equal to 0.6. So what do we write now? A is equal to what? A is equal to minus 90 into 90 divided by 2 into 0.6. So we get how much? Acceleration is equal to, we get A equal to how much? That is minus 6750. Minus means it is retarding force, retarding acceleration, retardation or deceleration. Now you have F is equal to ma. F equal to ma, then F equal to 0.04 into 67 minus 6750. Multiply it, we get the answer as 270 minus 270 newtons. This is the resistive force offered by the block. Once again, see here, mass. There is a bullet whose mass is 0.04 kg, and there is a block. Okay, so now what happens? This bullet enters with the initial velocity. Initial velocity of the bullet is 90. Displacement is 0.6 meters, and force is given to you. You have to find out the force. What is the resistive force? Final velocity is 0. Use the formula v square minus u square equal to 2as. Find out acceleration. Once you find out acceleration, substitute in the formula F is equal to ma. Now, next question. So the motion of a particle, which is 5.3. Motion of a particle of mass m is described by y is equal to ut plus half gt square. Find the force acting on the particle. This is 5.3 question. Example 5.3. Example 5.3. He says that the motion of a particle whose mass of the particle is given by m, and then motion is given by, the motion of the particle is described by y is equal to ut plus half g square. Are you understanding, girls? Are you understanding?
Yes, sir.
Yeah, please ask me if you are not understanding at any point of time. So he's asking, find the force acting on the particle. F is equal to how much? Now, this type of questions they can give in MCQ also. They look like, say, example questions we don't try. Actually, few example questions are very difficult to understand also. That's what I do. Example, then I'm going to the exercise now. So there are around 10 in example and 10 in exercise, which we have to do now. So F equal to how much now? So first we will find out velocity. How do we see? This is the displacement actually. How do we find out velocity first? Velocity is equal to v equal to dv by dy by dt. Okay, which is equal to how much? Derivation of t is 1, u into 1 plus half into g into 2t. 2 and 2 will go away. U plus gt. This is velocity. We need to find out acceleration again. So acceleration is what? dv by dt. So implies acceleration equal to d by dt of u plus gt. So derivation of constant is 0. 0 plus g into 1. So answer is a equal to g. Are you understanding? See, equation of displacement is given to you. First time derivative you do, you get velocity. Once you get the velocity, again differentiate one more time, you will get acceleration. So A equal to what? G. Understood? So now what we are going to do now? F equal to MA. F equal to MA. So F equal to mg. This is the answer. Is it clear? Is this clear? Girls. Is it clear?
Yes, sir.
Okay. Please note down this, then we'll go to the next question. So this book says, this numerical says, a batsman hits back a ball straight in the direction of the bowler without changing its initial speed of 12 meters per second. So sorry, without changing its initial speed. So what happens is the ball goes, hits the bat and returns back in the same direction. No change. So U equal to U equal to V, but U equal to 12 meters per second and V equal to minus 12 meters per second because velocity is having direction also. So mass of the ball is how much? 0.15 kg. Determine the impulse imparted on the ball. So here we have change in momentum. Change in momentum is what? MV minus MU. MV minus MU. So MV is how much now? Suppose this direction you are taking positive, this will be negative. So this will be U will be positive and V will be negative. Now MV minus MU. So linear motion of the ball. So MV minus MU equal to what? 0.15 into U is 12 minus M into 0.15 into minus 12. So that will become 2 times. So that answer will become how much? Minus. This will become plus. So therefore it will become 3.6 Newton second. Okay. So this much change in momentum is also known as impulse. Is it not? Yesterday we have discussed this. So can we quickly do a recap? So what is first law of motion? Newton's first law of motion. Can you say quickly what is Newton's first law of motion? Yes.
Body continues to be in the state of rest or motion unless acted upon by an external force.
Very good. A body remains to be in the state of rest or in the state of motion unless an entity is compelled by an external periodic force. So it gives the concept of this gives rise to 2 different concepts. What are they?
Friction and inertia.
Very good. Inertia and friction. What is friction?
Opposition offered to the motion of the body.
Opposition to the motion of the body is said to be friction. So how many types of frictions we have altogether?
4 times. 4.
4 types of friction. What are they?
Static friction, kinetic friction, rolling friction.
Yeah, static friction, maximum static friction or limiting friction, sliding friction or kinetic friction or dynamic friction. 4th one is rolling friction. These are the 4 types of frictions we have. So now come to inertia. What are the types of inertia? What is inertia first of all?
Inability of the body to remain in the state of rest or motion.
Yeah, inability of the body to remain in the same state of rest, motion or direction is known as inertia. How many types of inertia we have?
3.
3. What are they?
Inertia of
Inertia of
rest.
rest, inertia of motion, inertia of direction.
Very good. Inertia of rest, inertia of motion, inertia of direction. Very good. Next is what is momentum?
Mass into velocity.
Product of mass and velocity.
Momentum is mass into velocity. And its P is equal to mv. And what are the units? What are the units?
Newton second.
Newton second or kg meter per second. And is it a vector or scalar quantity?
Vector quantity.
Vector quantity. Very good. And what is the dimensional formula of momentum?
MLT minus 1.
MLT power minus 1. Very good. Perfect. Then what is second law of motion? Newton's second law of motion?
Rate of change of momentum is directly proportional to applied force.
Very good. The rate of change of momentum is directly proportional to the applied force and accelerates in the direction of the resultant force. Now, so we have the formula F equal to ma from there. Now, what is impulse? What is
Effect
impulse?
of force for a long duration of time.
Effect of force for a short duration of time is said to be impulse. Okay. Next one. What is third law of motion?
Every action
Every action has an
has
equal
an
and
equal and
opposite
opposite
reaction.
reaction.
For every action, there is an equal and opposite reaction, and they act in pairs. Next is what is
Pairs.
conservation of momentum. Conservation of momentum. Energy is neither, total sum of, in an isolated system, momentum is conserved, or sum of momentum before collision equal to
Sum of momentum
Sum
after
of momentum
sum of
after
momentum
collision.
after collision. Okay. So now, after that, we spoke about banking of roads and angle of banking. What is banking of road?
when the outer edge of the road is lifted.
Yeah, exactly. So what happened? The outer edge of the road, road is lifted upwards so that the body can take a smooth turn. The car can take a smooth turn. That is angle banking of road. Angle of banking means it is the angle with which the road is lifted upwards. That is said to be angle of banking. Now, so we have after this. We did two derivations. One is on level road, one is on bank road. Can you tell me the final formula for both of them? Bank road, so that is normal plain road, or what we say on a circular track, and the second one is on the bank road. What is the formula? Maximum velocity formula. Maximum velocity formula.
For motion of a car on a level road, that one.
Yeah. What is that?
Velocity is square root of mu rg.
Yeah, very good. Just a second. So now, okay, what is the formula for the bank road? Maximum velocity formula. Yes. You're not going through. This is very important derivation. These two derivations are very, very important. Please write and practice the derivation. Unless and until you write and practice, you cannot write in the examination. As the time passes on, the pressure of other subjects also will increase, and it will be very difficult to cope up. I'm telling you. So please have a good track on the grade 11 syllabus. Okay. Please practice the derivations, because we need to see once you are thorough with the derivations, then we can focus on the numericals. When you're not good at derivations, how can you focus on numerical then? First, finish off the derivation part and the conceptual part. So once you're done with that, then it will be easy for you. You'll be very confident and you can easily do the numericals. Otherwise, you'll be struggling with both concept as well as the numericals. That should not happen. And at the end, the subject will become very difficult. So now, question number 5.5, we'll go with the next question. Question number 5.5, he says that 5.5. He says that there is two identical billiard balls strike a rigid wall and with the same speed but at different angles and get reflected without any change in speed. What is the direction of the force on each of them? See here, like suppose there is a ball here, it hits at an angle. Okay, I'm not going to do the straight one. Straight one already we did. I'm not going to do that. Waste my time here. So going ahead, see here, this is the initial velocity. This is the initial and final velocity same. Now, this is the angle. It made an angle of 30 degrees with the horizontal. This is also 30 degrees with the horizontal. I am resolving this into components. So we did in the previous lesson. So when you resolve this into components, suppose this is the 30 degrees. These are the two components. So this is u, this will become u cos 30 degrees. And this will become u sin 30 degrees. Is it clear? Any doubt in that one? U cos 30 and u sin 30. This is horizontal component and vertical component. Next one, suppose if I am coming with this one. So what will happen here? Now this is horizontal and vertical. This is 30 degrees. Horizontal is what? U cos 30 degrees and u sin 30 degrees. Understood now? U cos 30 and u sin 30. So what will happen now? I am going to take the first x-axis, means horizontal ones. In horizontal one, u cos 30, they both are in the opposite direction. See? So we will take initial and final. P initial is what? M into us. Okay. M into u cos theta. M into u cos 30 degrees. PF equal to what? PF is equal to minus M into u cos 30 degrees. Understood? Should I write minus? Because see, this is in positive x-axis, this is in negative x-axis. Positive and negative. So that is why this is positive and negative. Is it clear? Is it clear? Yes.
Yes. Sir, could you explain again?
See here, I resolve this into components. This ball comes and hits the wall and will reflect back with the same angle, with the same velocity, same angle. Now, this is the initial velocity. Okay, this is the u. So we have two components. This is u cos 30, u sin 30. Similarly, if this is 30 degrees, so this is u minus u, that is u cos 30, and this is u sin 30. Horizontal will become cos, vertical will become sin. Now look at x-axis, the horizontal ones. This is positive and this is negative. See, because opposite direction. So m into u cos 30 minus m into u cos 30. So change in momentum is what? Pf minus Pi. So what is that? Pf is minus into mu cos 30 and minus into mu cos 30 and again minus into mu into cos 30. So that will become minus 2 mu cos 30 degrees. So cos 30 is how much? Root 3 by 2, right? Cos 30 is root 3 by 2. This and this will go away. Answer is what? Minus m into u root 3. But similarly, when I go for the y-axis, see, look at y-axis. This and this is in the same direction. This is also negative. This is also negative y-axis. So Pi is equal to what? Pi equal to minus m into u sin 30, and this is also Pf equal to also minus m into u sin 30 degrees. So that is what happens. Pf minus Pi is equal to what? Minus, that will become 0. Understood now? Is it clear?
Yes, sir.
Yeah. Please copy this, then we'll go ahead. If you any doubt, please ask me. Next question is question number example 5.6. See figure 5.8. A mass of 6 kg is suspended by a rope of length 2 meters from the ceiling. A force of 50 Newton in the horizontal direction is applied at the midpoint P of the rope as shown. What is the angle of the rope makes with the vertical in equilibrium? Neglect the mass of the rope.